Okay, let's be real for a second. The word algebra can sound a little scary. But what if I told you to think of it less as math and more like a really smart way to organize information? Seriously, once you see it that way, everything starts to click. So let's dive in.
Have you ever looked at something like, well, this on the screen? It just looks like a total mass of letters and numbers, right? You're definitely not alone if you feel that way. But stick with me, because I promise that by the end of this short explainer, this whole thing is going to make perfect sense.
So here's our game plan. We're going to start with the absolute basics, the language of algebra. Then we'll learn how to sort and simplify things, tackle those tricky brackets, and finally, see how this all works in the real world.
All right, first things first. Just like learning any new language, algebra has a few key vocabulary words. Once you know what they mean, you can basically understand the whole conversation. And trust me, it's way simpler than you think.
The most fundamental building block is called a term. Just think of it as one single piece of information. It could be a simple number like 7, or something like 5x, or even the square root of 2. These are the individual Lego bricks we're going to be working with. Now, inside those terms, you're often going to find a variable. This is usually just a letter like x, and it's basically a placeholder. Think of it like a little mystery box that's holding a number we just don't know yet.
And the number that's right next to that variable, that has a name too. It's called the coefficient. So in our example, 5x, the 5 is the coefficient. All it does is tell you how many of that variable you have. So in this case, we have 5 of whatever is in that x mystery box.
And finally, you have the constant. This one's easy. It's just a plain old number with no variable attached to it. It's called a constant because its value is, well, constant. It never changes. So in 5x plus 7, that 7 is our constant.
Okay, now that we've got the lingo down, we can start sorting. And honestly, the best way to think about this is like doing your laundry. You know you put all your socks in one pile and your shirts in another, right? Algebra plays by the exact same rules.
In algebra, we sort things into like terms and unlike terms. Like terms are the ones that have the exact same variable part, like 5x and 3x. Those are your socks. They can go in the same pile. Unlike terms have different variables, like 5x and 4y. You just can't combine them. It's literally the old apples and oranges problem.
All right, pop quiz, quick gut check. Look at 5b and 2b. Are they like terms or unlike terms? What do you think?
Yes, they are like terms. Fantastic. And why? Because they both share that same variable, b. It's that simple. You've got 5b's and 2b's, so they belong in the same family.
Okay, let's wrap it up just a tiny bit. How about these three? 3x, 4xy, and 5z. Are those like or unlike?
You got it. They are unlike terms. And the reason is, even though they all have letters, their variable parts are totally different. You've got an x, an xy, and a z. None of them match, so you can't combine them. They each get their own separate laundry basket. So you see where this is going, right? If you know how to sort your terms, then you know how to simplify. And simplifying is really just the fancy word for tidying up these messy-looking expressions and making them nice and neat.
And here's the best part. The whole process is just 2 simple steps. That's it. First, you find and group all your like terms together. Second, you just add or subtract their numbers, their coefficients. That's the entire magic trick.
Okay, let's put it into action. Here's our starting expression on the screen. 3x plus 5x plus 4y minus 6y. Looks a little cluttered, doesn't it?
Step 1, we sort. We just mentally scoop up the x terms, so 3x and 5x go together. And then we grab the y terms. That's the 4y and the minus 6y. We've put them in their own little groups. And now for step 2, we combine. What's 3x plus 5x? That's 8x. And what's 4y minus 6y? That gives us negative 2y. And that's it. Our clean, simplified answer, 8x minus 2y. See? We went from chaos to clarity.
All right, ready for level 2? Let's talk about brackets. Don't let them intimidate you. Just think of them as little packages inside the main expression. We just need to know the right way to unwrap them.
Now here is the absolute golden rule for brackets. The one thing you have to remember. You always have to look at the sign directly in front of the bracket. If it's a minus sign, this is huge. It flips every single sign on the inside. A plus becomes a minus, and a minus becomes a plus. That one detail is the key to the whole thing. Let's look at this example to see what I mean. The key here is that big minus sign sitting between the two sets of brackets. When we go to remove the brackets, that minus sign gets distributed. So the 4x becomes minus 4x. The minus 6y flips to plus 6y. And the plus 8z flips to minus 8z. Once you do that, it's just like before. Group your like terms, combine them, and you land right on that final answer.
So we've sorted, we've simplified, we've dealt with brackets, but this brings us to the most important question, right? Why? Why does any of this actually matter in the real world? Well, let's find out.
Picture this rectangle. It could be a garden you're fencing or a room you're putting baseboards in. You need to know the perimeter, the total distance all the way around. But what if the sides aren't measured in simple numbers? What if they're described with, you guessed it, algebraic expressions? This is where our new skills become super useful.
So we can take the expressions for each side of that rectangle, add them all together, and then just simplify them using the exact same rules we just practiced. And what we end up with is a clean, simple formula for the perimeter. And that really hits on the bigger truth here. Algebra isn't just about solving for x. As this quote says, it's a language for describing the patterns of the world around us. So the real question is, now that you know a little bit of the language, what patterns are you going to start seeing?